So to calculate backwards, if you have a pH and you're trying to find the molarity or the hydrogen concentration, we do the anti-log or the inverse log. And so there are a couple ways to do this on your calculator. You can use the second or shift key on your calculator and then do log and then whatever the negative pH is. So essentially we're trying to undo this negative log. Um, those of you who've done your trigonometry, algebra 2, pre-calc, you know that log is base 10. And so if we do 10 raised to the power of negative pH, it's the same thing as typing that in. So if I have a pH of 2.10 and I do 10 raised to the negative 2.10 in my calculator, I end up with 0.0079, and that's its molarity, its concentration. So those are units here. Notice before that pH does not have any units. pH is simply a number because it's a logarithmic function. So it's a ratio of base 10 essentially. But concentration is measured in molarity, so we want to be able to label that. In chemistry, we also are concerned with pOH, which most other sciences don't actually really care about the pOH. The pOH scale doesn't have any meaning for them. But in chemistry, it is important to know the concentration of OH. And so we can do those same kind of calculations. pOH is just then the negative log of the OH concentration, which bases generally have OH in them. So if our formula here has an OH in it, when we take the negative log of this number, we get a pOH. So the negative log of 6.5 times 10 to the negative 4 would give us a pOH of 3.19. So we can always calculate those as well. The thing is that, like I said, most sciences don't care about pOH. They only care about pH. And so for us to be able to go back and forth between the two, we have to know that relationship. pH plus pOH equals 14. And if you remember the pH scale, the total, the highest number is 14. And that's kind of where this comes from. So that's how we get that constant number. But if we know the pH, we can then figure out the pOH and vice versa. So in this example here, if we have a pH of 10, the pOH must be 4 because 10 plus 4 equals 14. So the pH and the pOH is always going to add up to be 14. And so here's a really good example of why we need to be able to do this, because we have this formula, NaOH, and it gives us the molarity of that. Well, if we take the negative log of that, we're going to end up with a pOH because this formula has OH in it. And so the negative log of 4 times 10 to the negative 3 is 2.4. But that's the pOH, and most other scientists don't care about that. They really want to know the pH. So to figure out the pH, I would take 14 minus this number to figure out what that is. 14 minus 2.4 would then give us a pH of 11.6. And so therefore we would know that this is very basic, which makes sense because OH indicates a base. So I'll have another video again with some more examples and some practice problems. But I also want to talk about indicators in this video. Indicators are anything that changes color depending on the pH. And so we have lots of indicators that we can use in chemistry. The one that you're probably most familiar with, you can't actually see the word very well, is litmus. Litmus paper is a pink or red color when it's an acid, and it's a blue or purple color when it's in the presence of a base. And so litmus is very well known. But there are lots of other indicators, and there are some indicators that actually occur in nature, like these hydrangeas. So again, look for another video about pH, and you'll have some practice problems to calculate, and indicators will come up again when we learn about titration.